I don't know if you know Arduino, but I will spare you the whole presentation about what Arduino does or doesn't do. You're welcome to check our website, arduino.cc, and ask any questions later. I'm also a researcher at Malmö University in something called the Internet of Things and People group. So I do a lot of things with Internet and things and people at the same time. I mean, we just started the project, so we really have no clue what we're going to do. It's a 7 years project, fairly large. There's a lot of money invested in it, and we will do great things because there is money. And I'm the head of the so-called Interactive Objects Department at Malmö University as well, which is a invented department with non-researchers that works in a garage. So we basically invent things all the time. But we're here to talk about the Internet of Things. So I will try to answer what it is. I will talk about some categories of devices, and I will talk to you briefly about what companies are doing out there in the world based on the research we've been doing through the last years. This is a very generic talk, so I think it's great. I'm actually opening because if I had to talk about IoT security, I would suck big time, okay? So, and then I have a second presentation about big data, but since I only have 20 minutes, I will not go into big data, but yeah, I will spare you that time. So the question is, where is IoT? And I really like to show this to my students, IoT according to Sony, or is Ericsson, or is Sony Ericsson? I'm really confused. No, but I guess you know this video, don't you? About the social web of things. I like it very much because the main actor is called David, just like me. It reminds me of the kind of pretty guy I used to be once, upon a time. So the whole idea of this video is basically that David is talking to his home, and he's telling his home, okay guys, I'm coming home, and having a girl over is going to be great. And there's his apartment. So it's packed with cliches. I really like it. First of all, it's using the IKEA, letters over furniture kind of paradigm. And then you see like the microwave is not used for cooking like nice, sexy dinners. I mean, I do sexy dinners on microwave all the time. Maybe that's why I'm this David and not that David, anyway. I still don't understand why the washing machine gets to wash before the girl comes for dinner. I don't know if it's to make the guy look cool or... It's a crucial moment. Sophia is not coming. I mean, this happened to all of you, didn't it? I mean, maybe it wasn't called Sophia, it was called something else. Probably I've seen this video about 80 times by now, because I use it in my classes all the time. So I know all the nuances, like why does the umbrella have to talk when we're talking about dinner? Has nothing to do, the umbrella is not in the car with him. He's gonna get wet anyway, But yeah, here's David. And here's whole 9,000 playing against Sofia. It's like, don't look at her, it's football on the TV, right? And there is no Sofia. There you go. So is this the future we want for ourselves? We want home to take control of our relationships and tell us that Sofia is not worth it? Well, guys, that's the IoT. Yes, you know me. So I usually explain the IoT from a different perspective because I like to look at where I think the challenges are, and challenges still remain at the very same place as 3 years ago when I started researching in this topic. And I take the alarm clock as the example of the device that we need to start looking at IoT. And I take it, and I really like to use my grandmother as an example. I'm not going to show you a picture of my grandmother. She's not like Sofia, so no rush. And I always like to speak about this example because my grandmother does not use anything digital except for a 7-segment display clock that she has by her bed. Of course, her TV is digital, her elevator is digital, her microwave oven is digital, but she does not understand the digital aspects behind any of those technologies. The only real device that is digital in her home, in her brain, is the alarm clock. And it's the only place where I think I could hack into if I wanted to get her a connected device. Okay? So if I wanted to basically tell her the weather on this alarm clock, and you know the weather is 2 bytes, you need 2 bytes a day. 2 bytes a day is 700 bytes a year, so it costs 0.0000 crowns to pay for 700 bytes a year. But as you know, it's impossible to get you a connection for 700 bytes a year in any provider. With Telia, Telenor, broadband connection, anything, it's impossible. Nobody's going to give you that connection. That connection, that alarm clock with a 1 gigabyte connection card should cost something in the range of, I don't know, making your clock like 100 crowns more expensive for the life of the clock, don't you think? But nobody's giving you that. So there's not going to be an alarm clock that can tell my grandmother the weather on a daily basis because nobody's going to give us the connectivity. If I want to have a connected clock for my grandmother, I need to have a Wi-Fi connection for her and make a clock that connects through Wi-Fi. And that's making everything too expensive. My grandmother doesn't have a phone even. But there is a model, there is a device that has been around for quite some time that already lives on this model, and many of you haven't even thought about it. The Kindle reader actually connects through 3G, and it downloads the book, but you are not paying a monthly subscription to the Kindle reader. It basically gives you free connectivity as long as you keep on buying books. So it is actually possible. The business model exists. It just does not exist for all the small devices you want to create because it's very complicated. So let's look at different types of devices within IoT, but in order to look at different devices, I would like to look at how to classify them. On the one hand, I like to look at personal networks versus always-on networks. A personal network will be something that exists only for me when I'm there. For example, I like to talk about the gym. You go to the gym, and all the gym devices could be BLE enabled and could be streaming information about your performance to your phone. And you could have your own performance tables in your phone. And as soon as you leave, that network stops existing and belongs to somebody else. It's personal, and it's only for me for that time. While you could have an always-on network that could be on the public transportation, measuring energy consumption, anything like that. And these two networks are actually following the same stack, which is IoT. And that's why it's very complicated for people to understand that in the end, IoT is about anything connected. So the way we like to look at it in Arduino is that we distinguish between the IoT of people and the IoT of machines. And both of them live together, but they have to do with personal interactions or machine-to-machine interactions. And I'm going to give you some examples of things that are connected. I'm going to go really quick. So the first one is an earthquake detector made by Sebastian. He basically hacked an earthquake alarm through an Ethernet board, and every time there is an earthquake, it tweets automatically, there is a vibration here in Santiago. And he got a lot of followers on Twitter that basically want to know when there is an earthquake alarm in Santiago. There is this invention from 2010 called Botanicals that basically tweets when your plants are running out of water. How many of you would kill for this thing? Well, this is now part of the permanent MoMA collection in New York. So if you have enough millions, you can probably buy it. It's one of the first Arduino compatible designs used for something practical. No, but I think it's a clever idea because basically it's reminding us how stupid it is that we need a machine to remind us to water our plants. Right? We cannot just look at it ourselves. There is a project I always like to quote. I don't know if you ever heard of a network called Patchbay or Cosm or Xibeli. It's basically a network to subscribe, where you can make publication subscription of sensor information. And it was created by a bunch of renegades from the architecture field. One of them is called Usman Haq. And Usman Haq has he lives as an artist most of the time, and he made a project called Natural Fuse. And the idea behind Natural Fuse is that you can have a fuse that is made of plants. As you know, the CO2 consumption of plants can be translated into energy consumption in general, so you can translate it into electricity. So if you have these plants, you can probably turn on this lamp 2 hours a day. So if you want to use your lamp, you only have 2 hours of electricity a day. So you really have to think about how much you're going to use it. Because if you overuse it, your system will detect it, will stop watering the plants, will kill the plants, and then your fuse will disappear, or you will have no more electricity. But also the plants, they have the possibility of connecting to others. You can run it in selfless mode or in selfish mode. In selfless mode, you're donating your remaining electricity to other people, and in selfish mode, you're basically sucking from other people. So if somebody has it on selfless mode, all people's plants can connect to your plant and suck the electricity and eventually kill your fuse and let you there without any more electricity for your lamp. So the idea behind Natural Fuse is to create this network of different lamps that collectively will transform a lot of CO2 in oxygen again, allowing all these different people to burn that oxygen again, in the form of electricity. This is just an art project, by the way. But it worked. You can check Natural Fuse. Then another interesting IoT network from the one that is permanently connected is the one that was established by citizens of Japan when they wanted to measure radiation at the time of the Fukushima tsunami and earthquake. So basically, population realized that they were not getting enough information or good information from the government, and a lot of different groups started to create their own tools to measure radiation and publish it online. So they used Usman Haq's patch-ray system to create radiation maps of Japan, and in that way analyze whether it was safe or not safe to move around and go places. Again, this might not be, this board might not give you a very scientific measurement of radiation, but if you get the red measurement, you start doubting whether you should go to that place. And that translates into this idea that individuals can actually join other individuals to create their own networks or maps, create their own maps of information around them. So the Smart Citizen project is a project that actually covers a whole vertical within IoT, from measuring data to map data to an app to look at data, and it's completely open source. So if you want to create your own platform to map information, you can use OpenStreetMap as a source of maps and this whole platform to build up your whole system. Okay. Well, this is within the personal net. So when I mentioned the gym, I mentioned it because Google actually, when they announced their Android Open Accessory Protocol, they actually used the gym as an example. So I like to use it because they used Arduino compatible boards to hack the gym. So as one of the Arduino makers, I find it very interesting to have a big company to copy our boards to make interesting stuff, right? And not pay us anything. But that is a different story. They're nice anyway. One of the things that we're going to see, and this is one of the biggest challenges within anything that has to do with making everything connected in one way or the other. I don't know if you know, but one of the first times we spoke about IoT was when we were discussing back in the days about marking everything with RFID tags. So if you can mark everything with RFID tags, everything can be localized in a way. So you can actually know where everything is to some extent. If you have readers, you can know that something entered a space or left a space or whatever. So it's actually possible to embed RFID tags in your own hand and then use your own body to become the interface to anything in the world and open doors, open your car, open your garage, and so on. We have a conversation about trying to replicate this live on stage while making this talk and just make a hole and put an RFID tag and start opening stuff. I will not do it, even though we talk about it at the office, but I will not do it for you. But this is real, so the question is really, where's the limit? How far can we go? How far are we ready to go? So where we stand at right now within IoT, I think, is that we still don't completely understand the real value of many of the IoT things we're seeing around. Of course, everybody understands that it's really good to know how delayed your bus is when you are going to go to your smart bus stop, or you can actually watch it on your app. You check, okay, my bus to go to this place, I was 10 minutes delayed, so I can stay here 10 minutes longer. Everybody sees that value, but there is a lot of other aspects that we still don't understand how far IoT will carry us to. Then we also know that technology does not really allow us full scalability. Like, can you imagine that all of you had 10 connected devices on 3G? You know what happens when you go to a conference and you have 1,000 attendants, right? 3G doesn't work, Wi-Fi doesn't work. I remember there was at OLEDEV here, the guy that hacked the first iPhone, he was going to make a demonstration of how he was hacking the thing through Bluetooth, and then he opened his phone and opened the screen and said, oh, I need to pair. Clicks on pairing, and there were 300 devices in the room with Bluetooth on, so he couldn't pair. You know, so that's one of the problems. That's one of the problems we have. You know, if everybody has this thing at full blast, the UI is not ready, connectivity is not ready, and the infrastructure is not ready. I don't know if you know that one of the biggest problems, for example, in base stations, and this is something I got to know from some engineers at Vodafone, nobody had told me before, is that you can only have this many open sessions on a base station at the same time. You can have thousands of phones on the base station making phone calls, but you can only have maybe 250 open because they pay per open socket. So their model is they pay per open socket, but they charge you per minute, right? So they cannot allow you to have 10 sensors with an open socket all the time, not sending anything, because they are charging them, but they cannot charge you because you're not sending anything. So that really is a problem within IoT. So you cannot have full mobility. And the most important one, we are not really ready to embrace what it means. We are not really ready to accept things like embedding, you know, NFC tags in our hand or, you know, our elbow for that matter. But the question is, what are companies doing then? How are they approaching this matter? Because everybody is selling IoT all around. So some companies like AT&T, for example, they have made a very clever proposal, and they sell you the connected home. It's called AT&T Digital Life. They will tell you Nest has made $3 billion selling their business, whatever. Okay, AT&T actually goes to any home and installs this thing for you. Not in Sweden, but they do it in the States for a pretty realistic price. So their offering is like $30 a month plus whatever for equipment and installation, and then it's there. They guarantee you it's going to work. Because one of the biggest problems you have is that who are you going to buy a sensor from? Who's going to offer you the cloud service? Who's going to offer you, you know, the app in your device and maintain it so that when your iOS goes to the next version, the app still runs? You know, you need a pretty large infrastructure to do that. So they basically offer you sensors and a dashboard on an iPad so you can connect your home. Telefonica is having a bit more of a techie approach, and they have created something called Thinking Things. And it's a set of bricks that you can plug together. So you can plug your own battery system. They have smaller battery systems and larger battery systems. They have connectivity, can be through Wi-Fi or can be through 3G. And then they have temperature sensor, PIR sensor, whatever. You just plug the things together and they automatically show up on a dashboard online, and you can say, okay, when this thing reaches this level, I want you to do this thing and send me an email, for example. So they are looking at more the concept of building things and moving them around. We will probably manufacture these devices from Arduino. This is one of the things we are discussing at this point. And then, of course, you all know about what's going on with the most sold device is Wearable. Wearable really fits very much into IoT. You know, Wearable ends up going to your phone, and from your phone ends up going to a cloud, and your data is compared with other people. You do it personally because you want to see if you're running more kilometers than your friends, or, you know, you're sweating more than your friends or whatever. And within Arduino, we do a lot of funny things. We do a lot of boards. And some of them really fall into the IoT category. Like, we design boards that, for example, can connect through 3G connections. We design boards that can act as a gateway home, like this one. This one is used for prototyping different kind of sensor systems. So we try to cover this by adding more stuff to our portfolio. And by collaborating with very small companies like Intel that have invented the Quark processor, which is basically a system on chip that is a full Pentium computer that has all the three things that you need for building IoT applications at the hardware level. You need connectivity. This thing has the PHYs that you need for Wi-Fi or Ethernet or whatever. You need security that you achieve by encryption. And you need the possibility of having over-the-air updates. You need those three things to develop hardware that can work on the IoT. I could extend myself in this forever, but anyway. So this very small company started by giving away 50,000 of these. So you might have one or you might not, which is the Intel Galileo. Basically, this thing compiles Arduino code. The difference between this and an Arduino board is that it has 256 megabytes of memory. So you never run out of memory for your programs. Yeah. And then you have companies like Cybele that offer you cloud services where you can essentially push in your data, have your data online, share with others, make RSS feeds so you can feed your own applications, etc., etc., etc. So since the guys from IBM are organizing this, IBM also offers similar services. I like to use this one because this was the company that Usman created. So it's a small company that started with 4 people and so on. But as I said, there is a long list of companies that have the same offering. You know, right now, basically, there's a whole lot of people that are just looking at the cloud services. And then there is all sorts of different projects, like Goodnight Lamp is a very nice project that went on Kickstarter and didn't make it. But, basically, the idea behind Goodnight Lamp is to have a set of lamps where the parents have the bigger lamps and the kids have the smaller lamps, and they can communicate with them, sending them signals and telling them, okay, now it's time to go to sleep, and they turn off the light or things like this. So it's actually kind of related to the concept that Henry was commenting earlier. But I guess we're here because we want to answer this really big question, which is how to make IoT. And you need to really look at the picture like this, you know, where you're going to have different devices, you're going to have existing commercial devices, and you want to connect to other services, and you want the things to connect to give you a dashboard with statistics, and so on. And in order to achieve something like this, you need to look at a vertical like this one, which is very complex to achieve or to reach by a small company. You know, you need to have the sensors, the gateways, you need to actually manufacture this stuff here, you need to have the sales force and the deployment force. Because in something like installing a thermostat, not everybody can install a thermostat. I can't, you know. I will gladly pay a couple of thousands to have somebody home coming and looking for the right pipe, where to put it, to make sure it controls my heating, right? So then you need to have a backend. And on top of that backend, you need to install services and offer people apps, because everybody accesses the internet through one of these, you know. So to make a company that can achieve all these things at the same time is really hard to start small. And the big problem we have right now, there's a lot of different standards for trying to do this thing in different ways. You know, Aljoint, thread, I don't know, you say it. You know. And this is where the big mess is at this point. The European approach, for example, is try to offer FiWare somewhere here, you know. So they offers you a single cloud architecture that can be federated, and you can send data from place to place, and you can have your own system. Again, IBM have their own service. It was called Blue Mix. Thank you. I mean, there is as many as sand on the beach. You know, it's hard. It's really hard to decide what you're going to use when you want to implement something. But I want to talk about the dangers. I always talk about these 2 dangers when I make a speech. I think they are funny, because I think there's a lot of things that we haven't anticipated yet. So one of them has to do with this board that we built in Arduino, and this is what I call the vampires. I like to talk about dangers like real danger, because I mean you could talk about tsunamis or whatever, but the real danger is the vampires. You know, somebody comes and sucks you everything. They're also called black widows in some countries. So the thing is that this board we designed together with Telefonica and comes together with a SIM card that has world coverage. So you can design something in Sweden and ship it down to China, and as long as there is, I took the wrong example because China doesn't have GSM. Ship it down to Uganda, and the thing you design here will work down there, okay? So you can be a small designer and only make 10 of this, and you get the world coverage in the card. So there was somebody that wanted to cover a certain field, I think it was a wine yard, and there were a couple of hundreds of these things to put sensors all over the place, and they were reporting back to a server somewhere. So it was a double jump. First it was connect to the GSM network, and then from the GSM network connect to a web server and make REST requests to send data back and forth. But they made a mistake in their software so that they only had a variable that said not connected. And if it was not connected, it was taking a random time for like a couple of seconds and try to connect again. But the non-connection could happen because there was no GSM network or because there was no server at the other end. So the server went down one day, things happen, and 100 and something devices every couple of seconds were trying to connect to the GSM network again, generating an endless amount of traffic on this very base station. And since these machines trying to connect all the time, they generated as much traffic as Liechtenstein in a day. So basically, you have the possibility of creating DOS attacks in a very simple way. These are vampires because they suck the whole bandwidth. When they do that, that base station becomes unusable for everybody else. And since we're using the exact same base station that we're using for connectivity, for voice, for our own data, that becomes a risk. Right? And on the other hand, I really like to talk about the zombies, which is the second risk, because the non-dead are really, really dangerous. I don't know if you know this rabbit. It's the first IoT device ever. It's the Navastat tag. It's the second generation. And it's from a French company called Violette, and it was made in 2007, I think. And then the company went bankrupt very quick. This rabbit was reading your email, and then moving the ears happily and doing different interactions. And it was just too advanced for its time. It came too early in the IoT history, I think. But they sold the company to somebody else, and then they went bankrupt again and sold the company to somebody else. And they were clever enough to open source the servers that command these rabbits. So you could actually install your own server and then just have your rabbit connect to it and then get the thing to read your email or send you whatever. But there were not that many people that could install these servers. So as soon as you knew that somebody had a server, you just connect your rabbit to it. And if it was getting like 800 rabbits on it, you were basically provoking a huge bandwidth on that person's server, and you were sucking his bandwidth, and the server will go down because the VPSs, they cut your bandwidth. So the rabbits will basically die. And then they will just put the server up again and will just wake up again. So they were dying and up, dying and up. They were like the zombies. They stop, they work for a while, and then they fall down. And then they smell you and then go back for you. So my rabbit was waking up in the middle of the night screaming in French. And luckily enough, I don't understand French, but it was very scary. Okay, so those are two of the big dangers that I have identified so far. I'm sure there are more. As soon as we have devices that we depend on more and more, that we connect to our body, we're going to see more and more of these things. We're going to see accidents happening in unexpected ways. Just think about whatever bracelet that measures your performance that has a slight error, and it makes you force yourself to unexpected limits because instead of telling you, hey, guy, you should stop now. I mean, that's another example. There can be endless examples that we're going to discover as we go, and we have to be clever enough as designers to stop those from happening. And that's my slide. Last slide, I can't speak anymore. I want to just announce the Nordic IoT Hackathon properly because we are co-organizing it, IBM and Arduino and some other partners. And this slide actually just summarizes what you can do with this hackathon. Anybody can apply. You're welcome to apply in teams. There is no monetary prizes. That's our rule. As we actually want to use the money to fly people in. So if we have a really good team from Austria, we will use the money to invite them over, and pay for their hotel instead of giving monetary prices at the end. It's open for professionals, students, designers, engineers, whatever. Any age, race, color, or religion. And what you see in blue is what already works today. What you see in orange is what's going to work in a month from today. And what you see in green is the areas where people can intervene. So you can create your own sensors out of some examples we're going to make to connect to the net through what we call the minimum viable device, which is basically a Bluetooth to Wi-Fi converter. So you can plug anything here and make it go to different cloud services. And there is two main topics are smart home and smart transportation. Smart home is sponsored by Aon. So the idea is that you will work within a framework designed by Aon, and ideally the winners will be contacted by Aon to try to implement the project further. And smart transportation is sponsored by Skånetrafiken. So those of you that are interested, Skånetrafiken is super, super interested actually in looking at new ways, new payment systems for buses, whatever information systems that can help people understand that your bus is really crowded, it might be worth waiting for the next one, or whatever ideas you have. And they really are putting a lot of money into making things happen, so that you know. Okay, that's everything I had to say. Thank you very much.